something. Let's see. I don't egg fried. I don't eat egg. I don't eat egg. Yeah, I don't eat egg right itself, but I eat like bread. They have egg in it. Oh no, that's fine. No, that's fine. That's fine. No, that's fine. I just don't eat like the egg by itself, like a boiled egg or cooked egg or something like that. All right, so shh. All right, we're gonna talk about stuff. Since you guys already finished, we're not gonna. Parametric is fairly easy. The only thing you have to know is do the second derivative. I didn't find any second derivative question, but you have to know the equation for the second derivative, and so that should be it. So let's talk about polar. Polar is x equal to r, r cosine theta, and y equal to r sine theta. Why do they have a different coordinates, different things? Because one is an x component and y is y component. Now, what is r? Yes, that's r is kind of like radius, but is the distance from it's radius, but r can be negative. That's the thing. If you think about radius, you don't think about negative radius. You think about positive radius all time. So let's show you that. How does it work? So let's just say if today is I'm going to give you a situation that you first of all you have to recognize what is the polar coordinate and rectangular coordinate. So this is x and y. This is a Cartesian coordinate. Cartesian is just normal x and y. Now polar, however, is a little bit different. And so polar is going to compose of r and theta. So for example, we're going to have a r and theta here. What does r mean? The r means the distance from the center to the thing, but r could be negative, however. So r and theta is going to be, let's say, if I say today, it could be like 2 and pi over 4. So that means pi over 4 is 45 degrees, right? So that means this is going to be 1 ring and a 2 ring. And it's going to be right here. And this is going to be 2 and pi over 4. Is that okay? Now you do see it on Desmos, so I do want to show you on Desmos. Desmos does have a polar coordinate. If you click on this, oops, that's not it. Why is logarithm scale? Hold on a second. Home and clear this, and then polar. It's to look like this. The only problem is this. The only problem is the polar equation does not they at least I don't know how to do it. How to do the coordinate in the polar equation on Desmos. I don't think you can do it. No. So you can try it because that's not right. So 2 comma pi over 4. This is not right because this is not pi over 4. So what I did is they think pi is 3.14 and that's 3.14 over 4. So it'll be like something like 0.75. So it'll be 2 and 0.75. What? Theta over 4 doesn't work because pi over 4 is the direction angle. So what they did is it's not gonna work. So they thought it's 2 and go up 0.785. So it doesn't work with Desmo, but the polar equation does work in the Desmo. So we're gonna show you how to do it in a second. Yes, we did, but we had to convert from rectangular to polar, polar to rectangular. You guys remember that or no? I remember learning the concept. Okay, let's just say this, right? let's just say if I have a Cartesian coordinate, let's say -2 and 2. And so the basic equation for polar equation is going to be r equal to x cosine theta. And, oh, sorry, x equal to r cosine theta, sorry. And y is equal to r sine theta. Now you're gonna say, well, how do I memorize that? This is actually fairly easy. If you solve for cosine theta is equal to x over r, which is inside the unit circle. This is x r is a cosine theta. So it's not a new memory. It's the same thing that you learned before. It's adjacent over hypotenuse. It's adjacent over hypotenuse. So you just move the r to the other side. Now, the other one will be tangent of theta is equal to y over x, and x squared plus y squared equal to r squared. This is how you convert let's just say today if I have a convert Cartesian to polar, and this is to convert polar to Cartesian coordinate or rectangular coordinate or Cartesian coordinate. So I will show you how to convert from one thing to the other thing. So first thing, this is what I teach in pre-calc anyway, so I just kind of give you an introduction, and that way you guys got exposed to correct things. So -2 and 2 is going to be right here. Is that okay? Yeah, Cartesian. Look it up. Cartesian. Cartesian coordinate.
It's Cartesian.
Cartesian.
Oh my gosh. Cartesian.
Did I spell it completely wrong?
Instead of a C, it should be an S.
Yeah, there's supposed to be S-I-A-N.
S-I-A-N?
Yeah. Yeah.
Okay. Okay. I'm sorry. I'm a fob. I'm a fob.
I don't know what that means myself.
You don't know? White people don't understand. Okay. So if I have a -2 and 2, right? If I have a -2, if I want to convert to polar, I can take this coordinate and convert to polar by using the tangent of theta is equal to 2 over -2. Is that okay? I can plug in the y and x. I can say tangent of theta is equal to -1. However, you have to choose the tangent. You have to choose the theta. The theta could be what? The theta is going to be 3 pi over 4. Is that okay? Or theta could be what? 7 pi over 4. 5 pi over 6. Jenny.
I thought we were talking about the second quadrant. That's fine.
Jenny, 5 pi over 6?
Yeah.
Yes.
In this case, why wouldn't we do tan inverse? Why wouldn't we do tan inverse if the only theta would be -5 over 4?
Yes. Yes and no, but we're gonna talk about that. So usually you can have an infinite amount of representation of polar coordinate to represent a rectangular coordinate. Yeah, something like that. Yes. So let me finish and I'll go over why that is. So theta is equal to 3 pi over 4. So then you can say, okay, well, I can plug in the x and y here. I can say -2 squared plus 2 squared is equal to r squared. So that's going to be 4 plus 4 equal to r squared. R squared is equal to 8. R equal to 2 square root 2. So it turns out this can be plus minus too. This can be plus minus. So what I'm going to do is I'm going to do it with first one. This is going to be theta. So then we know our r is going to be 2 square root 2, comma 3 pi over 4. if that's okay. That's gonna give you the same coordinate as this point, because you're gonna go 3 pi over 2 and go outside 2 square root 2, the distance away from the pole, and that's gonna be the same representation as this. Is that okay?
Does the data include the first quadrant?
Yeah, 30 data is all the way from first quadrant to the terminal angle. It's from here to here, which is here it's gonna be 3 pi over 4.
Is it 2 plus or minus?
What?
Is it 2 plus or minus
2 plus minus what?
Is that what it says? 2 plus or minus root 2?
Yeah, plus minus 2 root 2. Now, let's talk about why it's a minus. So you can technically get, guys, you gotta pay attention. You can technically get infinite among the representation. So could I choose a different path? I could. I could choose 7 pi over 4, which is all the way on this side, right here. But I could have said it's negative 2 square root 2. Because I can go to the angle and just go opposite direction than the direction angle. Does that make sense?
No. What? Yeah.
Okay, I'm gonna say that again if you pay attention. I can go to 7 pi over 4, so which is all the way here, right? 7 pi over 4. Now, instead of going this way, I can say negative, so that means going opposite direction, and to get to this coordinate right here. So that is the same representation. The both are same representation as negative 2, 2. Actually, you have infinite amount of representation. And that's why it's, plus pi plus 2m pi. The situation is this. Plus pi plus 2m pi is the thing. So now you're going to say, wait, what Joshua is saying, why can't I just do tan inverse is negative pi over 4? The thing is that they usually represent data as a positive angle, but can you represent negative angle? Absolutely. So you can use it as a negative pi over 4, but however, you had to pick negative r as well, because negative pi over 4 is at the third quadrant, or it's at fourth quadrant, rather than at second quadrant. So if you want to go opposite direction, you have to have a negative r. Some people are looking at me like lost.
So you use the negative of r to make sure it's in the right quadrant.
Yes, because if you're in the opposite quadrant, you're gonna have a negative r, because you're going to opposite. You're gonna go, if it's a positive r, it's gonna go same as the direction angle, but you can go to opposite the other way. Yes. Yes.
So the r is only negative when you go in the negative direction,
Or as a negative is if your direction angle is opposite to the quadrant. So for example, if I always 7 pi over 4, but my coordinate is right here, but same distance here. So if this direction would be 2 square root 2, right?
Yeah.
But if it's going this way, it's going to be negative 2 square root 2.
So
So you have to, because you want your coordinate to be this side, even your direction angle is facing this way, so you had to go the other way. You had to go negative r.
So
you just went it
r,
wherever the
so
coordinate
why
is.
is 3 pi over 4
Why is this a B?
Because 3 pi over 4 is this way and our point's up here.
Uh-huh.
So this is positive.
So you want it to be wherever you're.
But then when that 7 pi over 4 is this, but our point is still
Yeah,
over here.
because
Does it feel
instead
like
of before, you're on the wrong
So we
side.
have to go to the negative.
Oh, it's saying negative pi over four. Okay, I get it.
So Mr. Ye, can we get like on our test for something? We can get they can give us one, and then we're expected to be able to find the other one that's equal to it, like this.
Yeah, so but it will be a pre-calc test, not a calc test, because I'm just trying to give you a brief overview, because I'm worried about some of you guys. I can just teach you the slope and the integration. I can do that, it's not a problem. But the problem when you go to college, that when you're taking Calc 3, and then they say this, and you have my teacher never taught. Huh? I don't know. Anybody want to take Calc 3? Okay, so right now, what I'm doing right now is not on the AP exam, but just give you some perspective of what is a polar coordinate and what's rectangular coordinate. Now, if today we say, hey, I want to convert this back to rectangular, x and y. How do I do that? I just plug in the x equal to r cosine theta. And the r is what? 2 square root 2, right? Cosine theta, cosine 3 pi over 4. So which is 2 square root 2. What's cosine of 3 pi over 4? Jenny, what's cosine 3 pi over 4?
Cosine of 3 pi over 4 is negative 4 square root over.
Okay. Negative. Then it would be -2, which is that's what we got. -2 right here, right? And
You know why you
okay, unfortunately I can't get to it, but there's some. You can look up how to do certain thing, but the main thing you want to look up is how to take a derivative of polar. What's the dy dx of polar function? Okay.